this project began with this time series, and what it's showing is the nationally average number of heaviest one-day total precipitation events for the past 102 years, starting in 1908. Basically, these are the largest rain and snow events, and therefore that means they are the ones that have the largest impact on society because they're outside of what's considered normal. As you can see, it's reached its highest levels during the past decade, and basically it's increased by about 0.07 events during the last century. And this is a statistically significant upward trend. Because of this, we wanted to find out why this increase was occurring and what type of weather maker was producing these large amounts of precipitation. To do this, we classified the heavy events into 7 different rain producers, first by using an automated system to take out the tropical cyclones, and then the rest, over 9,000 events, we looked at manually, and I looked at a lot of those. So the first we had was the frontal system, which we're all familiar with, and then we also had the extratropical cyclone, which is linked to low pressure systems moving across the U.S. The next type was the tropical cyclone, hurricane, along coastal areas and contract inland as well. And we had the Mesoscale convective system, which frequently happens in the central U.S. during the summer months. We had the North American monsoon, which occurs in the southwest in the summer months. Air mass convection, which is caused by isolated heavy thunderstorms. And also upslope events, air moving up the mountains. So because we went back to 1908, we were limited by the amount of data we could look at that went back that far. So of course we looked at the precipitation amounts, so our heavy events up there in Michigan, and we could see the other heavy events around it. We looked at temperature data, and we looked at the day before, the day of, and the day after our heavy event, so we could see how the temperature changed at our heavy event during the course of that time period. We also looked at the pressure maps, so we could see where our low pressure systems were and our high pressure systems. This also gave us an idea of what the flow was like at the surface, so we kind of knew where the winds were coming from. The last thing we looked at was, if it comes up here, this was the Daily Weather Map series. These are produced by NOAA back to 1871, so we could see observations at the surface, what wind observations were near a heavy event, as well as what meteorologists charted for that day. So our one here was a frontal system. So what did we find? Well, for 5 of our categories, extratropical cyclone, mesoscale convective system, monsoon, air mass, and upslope, we didn't find a whole lot. They had the ups and downs each year, a little different each year, but no kind of trend that was contributing to our overall upward trend in heavy events. But what we did find was, for frontal and tropical systems, there was an increase. The frontal events increased by 0.05 events per century, so that accounted for most of our trend that we saw. The tropical systems accounted for the other 0.2 events per century. So now, what we need to find out is why these are occurring and whether more events are producing, there's more events, or whether each event is producing more heavy precipitation amounts per each one. So, understanding these types of weather producers are what are causing these heavy events help us understand why the events are happening. So it can prepare us all for the impacts of the large events occur. Heavy events like these test drainage systems in urban areas, causing street and small stream flooding that damage homes and businesses in urban areas. And also, it can endanger lives of anyone who decides they want to travel through these floodwaters. In agricultural areas, we have the heavy events that flood fields and kill plants in them, resulting in costly replanting, as well as causing increased erosion. In our mountainous areas, we have large amounts coming at once, causing landslides and sending structures down hills, as well as covering structures and roads with boulders and mud. So with these types of societal and economic impacts, we hope to further explore what is causing the increase in heavy events from the frontal and tropical systems during the last decade. So thank you.